Hello and welcome to the physics topic Forces 2. We're going to look at elasticity and the effect of forces on objects and also compressibility. So what's happening as the spring is moved or stretched, what effect is causing that, and also if you squash a drinks can, for example, can it return to its original shape? So you can see from the moving spring that from that example there, it's returning to its original shape. So what we need to think about is the fact that a force can also compress or stretch objects, and that's as well as pushing and pulling them. So stretching meaning make them bigger, stretch them out. So you wouldn't necessarily stretch that can out, but you would stretch the spring. And compress. So you can compress the spring back to be smaller, and you would also compress the can. You can compress the can to be smaller too. Now, when an object is compressed, it will change shape. You can also refer to that as it deforms. So it's worth remembering that some of the objects can return to their original shape after the force has been removed. And that's talking about how compressible it is and then how elastic it is. So focusing specifically on the spring, we know that you can stretch a spring and it will continue to stretch up to a certain point. You will know this if you've messed about with slinkies. So the idea is that when you increase the force added to a spring, the amount it extends will increase. And so you can calculate spring extension by Hooke's law. So the force applied is equal to the spring constant multiplied by the extension of the spring. That's how much the spring extends. The symbols used for this are F equals K times E. So I've given you a little reminder at the bottom there. The extension is the amount of extension, the amount of stretch that the spring has from its original length. Okay, it's important that you start with the original length and then measure the stretch. Now, there's work taking place for the spring to stretch by the transfer of energy. So you need to know that the energy is transferred from the kinetic store of the spring to the spring's elastic energy store. If you are unsure of the energy stores, you need to go back and revisit the energy unit. Right, what you will need to do is put using Hooke's law, we just flip that, is put using Hooke's law into practice and doing those calculations.